Hey scientists, we are doing the Acceleration 500. This is the third race in our NASCAR project series, and it's all about Newton's second law of motion. Newton's second law states that the acceleration of an object is directly related to the net force and inversely related to its mass. In other words, the more force we apply to something, the more it should accelerate. The less force we apply, the less it should accelerate. It's actually inverse for mass, which means the less mass something has, so the smaller or less it weighs, the more it should accelerate. The more mass or the more something weighs, the least or the less it should accelerate. My bad. I've recorded this so many times. All right, your challenge. With a toy car, straw, pennies, masking tape, and a ruler, you are going to prove that Newton's second law is correct. Our guiding question throughout this race is, how does mass affect the motion of an object? You're going to follow these three rules in order for all of our results to be consistent. The first is that you must use a toy car. So your toy car can come from your lab kit that you picked up at school, or it could be anything similar. You must create a car with three different masses. You're going to do this by adding pennies on top. I included 5 pennies in your lab kit. You can use as many as you want, but I could only give you 5. So what this means is, for every race we've done, we've changed a variable 3 times, and then we've done 3 trials. So the variable you will be changing is the mass of your toy car. So you'll have 3 different masses that you'll run your race for. And then the final rule is that you're going to be blowing air into a straw to create the force that moves the car. Because the only variable we are changing is the mass of our car, we must keep force the same, which means that you need to blow the exact same way for all 3 trials. What I would recommend is just taking a deep breath and blowing out the air as one big exhale. And then I would also recommend timing it. So 1, 2, 3, and then you're done. Again, we want to make sure the only variable we're changing is mass. We're keeping force the same. So this is what your setup is going to look like, and I'll go through a demonstration in just a moment. You have your straw, you have your starting line, ruler. I've got tape around my car to hold my pennies on top. So all of these materials were in your lab kit. The only thing you need to provide is the tape. Before you actually get started, I want you to make a prediction. So again, our guiding scientific question is, how does mass affect the motion of an object? And what I want you to do is record your prediction below in this yellow box. Our procedures: after you've gathered those materials, you need to decide how many pennies you will add to your car each time. So what will your 3 different masses be? You're going to place your toy car on a flat surface, and you want to make a starting line. So let me adjust the camera so that you can see what's going on here. All right. After you've created your starting line and you found the surface that you're going to race on, you want to put your car at the starting line, and you're going to use your straw to blow the air on the back of the car to get it to move. Again, it's super important. We want to maintain that force throughout the project, so we want to be very consistent about it. So let me show you an example while we're here on this procedure page. I'm going to take a deep breath. I'm going to count to 3, and that will be the force I apply each time. All right, as you can see, my car didn't go very far, but what I would do is I'd use my ruler, and I would measure that my car traveled exactly 5 centimeters. So number 5 tells us to measure in centimeters, which is all your rulers in your lab kit are able to do. And you're going to record it in the data table on the next slide. You're going to repeat exactly what we just did with the same amount of mass 2 more times. So what I did here was trial 1. I'll do it again for trial 2, again for trial 3. I'm keeping the mass the same until I get to the next round. For the second round, I'm going to change the mass. I'll add a penny, or you can add however many pennies you want. And then I'm going to repeat steps 2 through 5. So I'll add my pennies, get my car to the start line, have my ruler ready, make sure I'm applying the same amount of force, measuring how far my car goes, entering it into my data table, and then going into each other trial. So trial 2 and trial 3. At the very end, you're going to calculate the average distance that your car traveled. So here's the data table. Again, in the yellow column, that's where you'll record your 3 different masses, and you'll do a race for each mass. The red is for each trial. So for me, I had 1 penny in my first round. My first distance traveled was 5 centimeters. I would repeat that 2 more times, again, with only 1 penny. I would then calculate my average here by adding trials 1 through 3, dividing by 3, and recording. You'll do your second mass here with 3 trials, your third mass here, again with 3 trials. Once you are finished, you're going to click this link here to go to a Google form to submit your results. I will announce the winner for who was able to get their car to travel the farthest next week. We'll do top 3, so first, second, and third place, and I'll mail you your very super special, fantastic, incredibly rare, insanely valuable prize. Let's take a look at the Google form. Okay, for the Google form, it always does this. I'm so sorry. I'm not going to record. We're just going to go back in and find the right form. Go here. If you're still watching this video, thanks for your patience. Okay, so you've got your first and your last name. You're going to tell me your social studies teacher just so I know what side you're on. Then you have science. I want to know what was the farthest distance your car traveled. You're going to share the average, and I want you to include your unit of measurement, which is centimeters. So when I say average, you're only worried about this blue column here, okay? It's the only one we're worried about. Let's see. You also want to tell me how many pennies were taped to the car for your farthest distance. So if my farthest distance was 5 centimeters, I'd say the average was 5. Say I did all the 3 trials, you know. I'd say it was with 1 penny. And then the final question, how does mass affect the motion of the object? The same question you made your prediction about. We're going to come back now after you finish the race and answer it 1 more time. And then next week, we'll announce the winners. If you have any questions, please email me or comment on the assignment. For my first and second period friends, I won't see you on Monday. I won't see you until Thursday. So I hope you have a great time. Otherwise, I'll see y'all in class. Have a great day. I love you to bits. Take care.